Hello, good afternoon. Our group topic is past, present, and future 3D printing in construction building. My group member's name is Rose Asnita binti Jamaluddin, me co-worker lagi Nanda Jadian, Nur Fatin Anissa binti Muhammad, Nur Azika binti Zainal Abidin, Siti Murni binti Junaid, Siti Maisara binti Nuriza. Introduction about 3D printing in construction and building. Construction 3D printing is a method for manufacturing concrete, polymer, metal, or other materials layer by layer using a 3D printer to create construction pieces for full buildings. The most prevalent form of printer is one that uses a robotic arm to extrude concrete back and forth. Construction demonstration, housing, construction components, cladding, and structural panel and columns, bridges and civil infrastructure, artificial reefs, follies, and artworks have all been created utilizing 3D printing technologies.
Next is application of 3D printing in concrete construction. In the construction industry, 3D printing can be used to create construction components or to print entire building. Next, history of 3D printing in concrete construction. In 1984, Charles Chuck invented stereolithography, a method of 3D printing where a designer creates a 3D model that is then printed layer by layer into a solid physical object. In 2006, Dr. Pedro Cosnevis of the University of Southern California unveiled the counter crafting system, an enormous 3D printer designed to literally print a building in place. In 2015, the Dutch 3D printing firm MS3D began printing a full-scale steel bridge to be installed in downtown Amsterdam. In April 2016, another Chinese company claimed to have printed 10 houses in 24 hours.
Current 3D printing technologies in construction and building. There are two techniques, which is the extrusion base and the powder base. The extrusion base is analogous to the fuses depositing modeling (FDM) method, which extrudes community-based material from a nozzle mounted on a grain train. While the powder base is another typical AM process that creates accurate structure with complex geometries by depositing binding liquid.
Application of 3D printing in concrete construction. The freeform construction will enhance architectural expression, where the cost of producing a structural component will be independent of the shape, providing the much-needed freedom from the linear designs. When compared with conventional construction processes, the application of 3D printing techniques in concrete construction may offer excellent advantages, including: first, reduction of construction costs by eliminating from work. Second, reduction of injury rates by eliminating dangerous jobs. Example, working at heights, which will result in an increased level of safety in construction. Third, creation of high-end technology-based jobs. Fourth, reduction of on-site construction time by operating at constant rate. Fifth, minimizing the chance of errors by highly precise material deposition. Sixth, increasing sustainability in construction by reducing wastages of formwork. Seventh, increasing architectural freedom, which will enable more sophisticated designs for structural and aesthetics purposes. Eight, and lastly, enabling potential of multifunctionality for structural or architectural elements by taking advantage of the complex geometry.
How 3D printing will affect the construction industry. 3D printing is a hot topic with clear benefit in many industries, especially medical, aerospace, and engineering fields, where creating tools and part to precise dimension is essential. The use of 3D printing in the construction industry has also garnered a lot of hype around use cases, such as in 2021, Madagascar School in production for half the traditional cost and sustainable design, and 2021, Fibonacci House in Canada boasts curved walls printed at the same cost as straight walls. Next, the benefit of 3D printing in construction. First, faster, affordable construction. It is where a build may sometimes take weeks or months to complete. With 3D printers, the work can often be accomplished in mere days and hours. Now, additional build time is available for more projects, which lowers overall construction costs. And lastly, reduce health and safety risks. In construction, especially concrete work, can be hazardous, but with 3D printing, the risks are minimal. So a whole lot less workers' compensation paperwork to file.
The advantage of 3D printing or future in construction. The first one is high cost. The expense of owning or renting such equipment, as well as the logistics required to bring this massive 3D printer to the project site, are two key roadblocks to wider adoption of 3D printing technology on construction sites. The second is quality control. Weather can already hamper construction project, but 3D printing has the potential to exacerbate Mother Nature's issue, where the environment concern and other factors could all play a role in making 3D printing in commercial construction a fail rather than a boom. The third disadvantage is regulation. Construction is expanding and competent workers are in short supply. The only issue is that there aren't quite enough. Even with the labor shortage, 3D printing requires a more specialized skill set, requiring a smaller and more limited pool of candidates. And the last advantage is labor shortage. One downside that may not immediately spring to mind is the regulation of 3D printing. Despite the fact that 3D printing regulation has recently made headline, it has yet to make a big impact on the construction industry. However, using printer instead of human to do various building does carry a danger of lack of accountability. That's all from our group. Thank you.